All right, students, today we're going to be working on pages 74 and 75. Sorry, my cats are being silly. Okay, so you need to go ahead and set up your notes. This is still going to be math. 8.3. If you have room on the page that you used yesterday, go ahead and use that. So, we're going to continue working. So you need to mark number 3 on the side of your paper. We're going to start on number 3 on page 74. A piece of fabric 4 meters long is cut into 2 pieces. The first piece is 1.25 meters long. How much longer is the second piece of fabric? So they kind of show you in the book how you're going to set this up. So we have the first piece is 1.25. So I'm going to leave it right here. And I'm going to mark this as 1.25 meters. So that M represents meters. The second piece, now the logical thing for you to think about is, okay, well, I don't know what that second piece is yet. However, I know that I had a total of 4, and I've only taken 1.25 away from that. That means that the second piece is longer than the first. So you're still going to start it off at the same place you did the first piece, but it's going to be a little bit longer. You don't have to know how much it is yet for it to be longer. We also don't know how much longer it is. We don't know how long the second piece is, but we also don't know how much more it is. But what we do know is that the total amount of both pieces of fabric equals 4 meters. So that is how I would set up this problem. I know the first piece is 1.25 meters. I don't know the length of the second piece, and I don't know how much longer it is than the first piece. But I do know that it is longer than the first piece because there was only 4. I only took 1.25 away, meaning that it would be longer than the first piece. So what I need to do first is I need to find the length of the second piece. So what I would do is take away 1.25 from 4 to find the total length. So let's do that right now. I would set this up as 4.00. Now 4 goes on top because it is larger than 1. However, it has invisible numbers behind the decimal, so I have to add them there in order to subtract my other decimal from it. If I were to just have 4 and try to subtract my decimal, I would confuse myself. So I'm going to set up my problem, and it should look just like this. Carry down my meters so that I don't forget. I cannot do 0 minus 5, and I can also not do 0 minus 2. So I have to go all the way over to my 4 to borrow. This becomes a 3, and then this would become a 10. Well, I still have to bring 1 over to this 0. So I'm going to take another 1 away, and this becomes 9, and now this 1 becomes 10. So 10 minus 5 is 5, 9 minus 2 is 7. Carry down my decimal, 3 minus 1 is 2. So the total amount of the second piece is 2.75 meters. That should make sense. It should be longer than my first piece. So the second piece is 2.75 meters. But what I don't know is how much longer it is. This is what I'm really trying to figure out of the answer of the problem. So what I need to do now is subtract 2.75 meters minus 1.25 meters. So that's what I'm going to do now. Set that problem up. 2.75 minus 1.25 meters. Bring down my meters. This becomes a 0. 7 minus 2 is 5. 2 minus 1 is 1. So the second piece is 1.5 meters longer than the first. So that is how I would set up my answer sentence. It gives it to you already. So the second piece of fabric is 1.5 meters longer. And you can end it there, or you could say then the first. Period. So, fairly simple. It just requires a bit more steps than yesterday. So let's move on to number 4. Number 4 says, Randy spent $29.85 on a soccer uniform and $18.75 on soccer equipment. He paid the cashier $50. How much change did he get? So, before we start to solve the problem, we have to figure out how much Randy spent on the uniform and the soccer equipment. So I need to go ahead and add those two things up. So I have $29.85 plus $18.75. 5 plus 5 is 10, carry my 1, that's 9, 9 plus 7 is 16, 1 plus 9 is 10, plus 8 is 18. That would be 3 plus 1 is 48.60. I need to make sure I bring down my decimal and my dollar sign. So, this is the total amount that Randy spent on the soccer uniform and the equipment. Now I can draw my bar model. So, I'm going to put uniform, equipment as my label. And I'm going to squeeze my bar right in here. This represents $48.60. Now, Randy spent and only had $50, which is not much more than what he spent. So this is $50. What we need to find out, though, is how much Randy got back in change. So we don't know how much he got back in change. This little portion right here is how much Randy would have gotten back. So in order to figure that out, all I need to do is take the 50 minus the 48.60. So let's go ahead and do that. So in order to figure that out, I'm going to take and put my $50 on top with my 2 zeros behind the decimal place and subtract 48.60. 0 minus 0 is 0. I cannot do 0 minus 6. Oh, cannot do 0 minus 8. So I have to go all the way over to 5 and borrow. This becomes a 10. Now it becomes a 9. This becomes a 10. 10 minus 6 is 4. Bring down my decimal. 9 minus 8 is 1. Randy was handed back $1.40 and change. So we're just going to write he got $1.40 in change. Period. That's all he received back. That's exactly how I would set up that problem. It might seem like it's a little daunting at first, but it's really not that hard once you get the hang of it. And if you would get stuck on borrowing and regrouping and this kind of trips you up, you are welcome to ask me questions during the live session and I will work out some problems for you. Okay, so last one, we're going to do number 5. That's on page 75. Nathan jogged on Monday and Tuesday. He jogged 4.55 kilometers on Monday and 1.78 kilometers farther on Tuesday than on Monday. What was the distance he jogged on both days? So, this is a multiple step problem, but don't get too nervous with it. It's not as scary as it might seem. So first we're going to draw out Monday. He went 4.55 kilometers. So we're going to draw this out, and this is going to be 4.55 kilometers. Make sure you label KM. So remember, just a reminder, you're not sitting here and trying to figure out how long 4.5, you're just drawing the bar and saying that that bar represents 4.55 kilometers. Okay, you're not trying to complete calculus and rocket science to try and figure that out. Do not be afraid of that. Just draw the bar and label it as 4.55. So, Tuesday. On Tuesday, he went further than he did on Monday, and it says that he went 1.78 kilometers farther. So that means that this bar is going to be longer. We don't know how much he went on Tuesday. We don't need to know how much he went on Tuesday. They don't ask us that. It's not required to complete the problem. But what I do know is that this amount right here is 1.78 kilometers because he went 1.78 kilometers further. What the problem asked for us to tell us, or to tell the answer for it, is how much he went on both days. So, by having this amount right here, this tells me what Tuesday will be. And then I can add Monday and Tuesday together to figure out how far he went on both days. So, what I need to do first is add 4.55 kilometers to 1.78 kilometers. So I can do that and set that up right here. And I'm going to go ahead and bring down my kilometers so that I don't forget. 5 plus 8 is 13. Carry my 1. 1 plus 5 is 6 plus 7 is 13. Bring down my decimal. 1 plus 4 is 5 plus 1 is 6. So on Tuesday, he went 6.33 kilometers. Okay. So now that I know Tuesday, I can begin to work on my problem to find the complete answer. So I would just add 4.55 kilometers plus 6.33 kilometers. This is going to give me the total he went on both days. 5 plus 3 is 8. 5 plus 3 is 8. 4 plus 6 is 10. So on both days, he went 10.88 kilometers. So my answer sentence will say something like this. He jogged 10.88 kilometers on both days. So, for each one of your word problems in your workbook, you will use a bar model to show how you got the answer. It is required, always required. Just because we are not at school does not mean that you don't get to use a bar model. You're going to be sending me pictures of your work, and I'm going to be checking it. If you choose not to use a bar model, you will redo the problem on a separate sheet of paper. It is very, very, very important that you know and understand how to do these and how to set them up. We've talked about this in class, but because we are not in school right now and we're not getting to do these together in person, I cannot help you as much. And I want to make sure that you are ready to go to 5th grade prepared to do these problems. It is super important. I cannot stress that enough. So if you have questions on how to set up these bar models or what is required of you, you need to be emailing me or coming to the live sessions at 10 or at 6.